Hello, all. I'm Vidya Sagar. Today I'm here to explain about filters, mainly of moving average filter and first order derivative filter, mm, 3-pointer central difference filter. Uh, Firstly, what is filter? Why filters are required? Mm, in a signal processing, a filter is a device or a process that removes some unwanted components or features from a signal. Filters are widely used in electronics and telecommunication, in radio, television, audio recording, radar, control systems, music synthesis, and some image processing also. Some of the major filters are like low pass filter, high pass filter, sorry, band pass filter, bandwidth filter, notch filter, etc. So, now let us see what is about moving average filter. Mm, Uh, this is the code for moving average filter. Um, um, MA filter is actually a simple low pass filter and it is a finite impulse response. A filter commonly used for regulating an array of sampled digital input or input. Sorry, it takes some samples of input at a time and takes an average of those inputs and we'll get it as a sorry, the average of those inputs will samples will be output for the moving average filter. Here I declared I took some thousand samples in float data type of X and I gave a length of like 8 and I declared output of Y. Uh, Here at this for loop actually summation occurs, uh, and this is for printing in output and this is for printing input. So let us check the plots once. So you can see the plots here. The red one is actually input sample and the blue one is output sample. The blue one is even smoother when compared to the red one. Red one is full of it comes of lot of unwanted signal and unevenness. So moving average filter actually makes a makes a makes the signal even more smoother and even. That's all about moving average filter, and let us see about first order differential filter. This is first order difference filter. Mm, Here also I gave some thousand samples as input. Actually, for this, for first order difference filter means suppose x of I is input, x of n is input, then output will be written as y of n is equals to uh, y of n is equals to x of n minus x of n minus 1. That will be the first order difference of respective samples. So here I took some thousand samples and I gave a actually here I gave the moving average filter output as first order difference order input. So you can see here this code is actually for getting moving average output and this is for after getting first order difference filter. So here in serial print I printed output output for first order difference filter and again printed this is for printing moving average output. So let us check the plots here. Plots for first order difference filter. Here I gave I need to get two plots here. First one is the first order difference filter output and I gave the moving average filter as input here, so YFI. So the tools and see the plot. See here, see here the red one is actually YFI as that is input of first order difference filter and this is the blue one is the actual output for that. See, the peak is reduced. We know that, right? As we move different. This is all. Let us see about 3-point difference filter. And this is central difference. Again, I actually took some thousand samples and I declared YFI is a float data type, and that is actually a moving average output. Like YFI is you can see this is actually code for moving average output. So YFI is we will get YFI as a moving average output of some thousand samples of X. Now I gave this YFI again as input for the central difference filter. You can see here, and now the serial.print will print our required central difference filter output. So it will print the moving average output YFI, and this will be the sample. So we'll check the plots here now. Here we have to get three plots. So